Hello, everyone. It's a pleasure for me to start the first oral blocks. Today we have 6 in total. The first 3 are in this skill. Let me introduce to Professor Cleber from Brazil. Thank you so much to be here.
Hello, everyone. Thank you for having me here. And after Professor Octavio, there is no way you have my more interesting approach. But as I'm presenting like a sequence classification, you can pretend it's she, maybe giving like a very interesting explanation. Well, I'm Cleber Zanchetti. I'm professor at Federal University of Brazil, and today with my colleagues Dayvid, Castro, and Byron Bezerra, I will present an approach for handwriting recognition. And we are specifically dealing with hard constraints for application of this problem. And offline handwriting recognition is a classical approach for pattern recognition. The idea here is try to extract text from images. And I know we have like a lot of good models doing that, but normally they struggle when they have hardware restriction, because we need like very big models to work with. And this is still an important approach, even with the digital transformation we have, specifically for personal notes, official documents, and archives. And this kind of restrictions is still a problem on that. And if we look back, when we have a lot of improvements, we start from recognizing numbers and digits, words, and then we go from segment lines. And right now we are able to extract all the information of a document without any kind of segmentation and doing even the layout transcription. And to do that, we are using very big models like recurrent convolutional neural networks, or specifically transform-based models that can like make a transcription of the information without any kind of segmentation, using a single frame to do that. But the problem is those kind of attention operations they do is they are very complex in both time and space, and then they are normally quadratic. And then we have like more complex image, and specifically to deal with handwriting, we need a lot of resource to do that, and we are trying to improve this kind of problem. And to improve the performance, we start from the state-of-the-art models and try to understand why they spend more time and resource to doing the work. And we are proposing a new approach, considering an encoder decoder approach. The encoder part, we are using reducing the space, like the spatial recurrence of the information. We are using convolution, octave convolution, to reduce the information we can deal. They use a kind of feature maps in a lower resolution to deal with the recurrent information. And then in the decode part, we are dealing with flash attention and multi-head attention to have a more speed process of extract information. And the key features of our approach are using octave convolution. This is a multi-scale strategy to use a lower version of the information, try to not using all the information to process. And then after that, use a gated convolution, which is a special way of spatial attention. Then we are able to focus in specific parts of documents. This is important when you are doing the layout extraction. And after that, in the decoding part, we are using a kind of memory efficient attention and flash attention for specifically extract information, and not using so much resources specifically for memory and GPUs. And to experiment with, we try to use a very hard data set. We are using historical documents because normally they are big, and the system we have right now, there is no good results on that. And we have two tasks in experiments. We have a single page when the one specific model, single model, try to recognize the whole page, the structure, and the text. and the double page when we have two pages in a single image, and the model needs to understand the layout of the information and organize information during the instruction. In the single page document results have very good resolution, and the answers the model we are proposing here, we also use another constraint. We have the answer max, when models normally use 48 gigabytes of GPUs to work. And then we are trying to reduce this amount of information because we are trying to do this kind of process in the edge. I know 12 gigabytes is still a lot, but we are going in the direction to reduce this. And even when we are using only 12 gigabytes against 48, we have like 3 times more samples processed. We also have a peak of processing the GPU on 3.5 gigabytes, where the other state-of-the-art models have 9, like 6% of reduction, where it's interesting. And we also are able to deliver more throughput. The amount of information we can process in the same time and with the same resource can be increased by 30%. When we are dealing with 2-page documents, as they are bigger and we need more memory to process that, we still have very good results considering this. We have the best results in recognition, and even in the throughput, we are in a good position. It's not still the same with the answer because we have restrictions of memory, but we can deliver the best results considering faster than with the state of art right now to do this approach. And when we are considering different metrics to evaluate the performance of the model, when we consider like GPU consumption versus training, when we can like reduce the use of the GPU during training, then we can even put more information during the training. We have the best results in this trade-off. When we evaluate the throughput to training, that means we can like put more bags or more memory during the training to increase the use or maximizing the use of the GPU. We still have the best results. This is important because normally we need a lot of information to have good results in this kind of application. And also, if we consider the memory scalability, and as we increase the number of lines of tests we're recognizing, our approach is better to have the results considering the other approach. And even for the latency inference, we have better results as we are increasing the batch size. Our model have better results delivery, and the other approaches are increasing the use of resources. And just a final remarks, we believe this model could be like a baseline for approaches in this field, because we are going to user approach, trying to process in the edge. And I think this is very potential, specifically when we are trying to bridge the information we have to the digital transformation and the information we still have in documents, specifically in archives. Thank you very much for that.
Thank you, Cleber. We have time for a couple of questions. Then, questions?
Yes, thank you.
In the data set, you have multiple pages.
Yes.
And so you segment the page into it?
No. The model needs to do that. Like you have a book, like an open book, and then it needs to understand the layout of the information and extract in the correct order, and just using a single model to do that in one task. Yeah, you can have that, but normally in this specific data set, they are high resolution information because they are like historical data when they do in the libraries. It's about like one image is like 5 megabytes.
Maybe I missed this, but at some point you had said something about recurrence being used very popular 5 or 6 years ago. Do you still think that recurrence, maybe I missed this, is it still being used in what you're saying today?
No, actually we start with that. Right now it's all transfer-based models. Yeah. And then this is a problem because normally the attention process is quadratic, and then on time and space, and then we are focused specifically on this here.
Thank you so much. If you have more questions, you can find in the post session in the afternoon.
Thank you very much.
Thank you, Cleber.